Hi, Algebra 2, and we find ourselves at the end of another week. Okay, so as we wrap up this week, we're going to start off real quick. Let's review briefly probability from yesterday. Remember, we assessed kind of a standard deck of cards. So a standard deck has 52 cards. We want to know what's the probability if I randomly draw a card from that deck that it is, in the case of our first problem, what's the probability that it is an ace? Okay, right here. So if we look, there is 1, 2, 3, 4 cards that are aces. Okay, so we put 4 possible over 52 is the total amount. Now, several of you did a great job writing your initial ratio. However, you forgot to reduce. Okay, so 4 does go into 52 13 times, so this can reduce to 1 over 13. If you are able to reduce, let's reduce. Otherwise, leave it as a fraction. Don't give me a decimal. You could do that, and sometimes you might be asked to, but for this chapter, just keep it easy. Just everyone leave it as a fraction. Okay, so our second one here, it says, what is the probability that we have a red card if we randomly draw? So if we look, there's 2 suits that are red. Okay, 13 of each color. I'm pointing them out here. So 13 and 13 is 26. We know there's 52 total cards still. Okay, so those 26 over 52, which, as we hopefully know, will reduce down to 1/2. Okay, so once again, don't forget to reduce if you can. And then our final one here, kind of in our warm-up, is what's the probability that we would draw a face card if we would randomly draw a card? Okay, so if we look over here, face cards are Jack, Queen, and King. In each suit, there are 3 of them. So that means 3 times the 4 possible suits gives us 12. 12 over 52. Now, once again, both of these are divisible by 4. 3 goes into 12, 4 goes into 12 3 times. 4 goes into 52 13 times, and we're left with 3 over 13. Okay, so those standard problems, just like we did yesterday. Now, today we're going to talk about something called a probability of compound events. So if you look right here, the word compound. Okay, now, a compound word, several of you probably know, it's a word made up of like 2 different words kind of put together. Okay, so a compound event is when there's multiple events happening. Okay, so it says here, when you consider all outcomes for either of 2 events, A and B, you form the union of A and B. Okay, and when you consider all outcomes shared by both A and B, you form an intersection of A and B. So what I mean by the intersection, that would be this region that's shared in the middle. And this whole thing, okay, all of this is called the union of A and B. Now, if we think about it, sometimes the union of A and B will look like this first picture. If event A, say, is who is in 10th grade, and event B is who is a boy, okay? There is a section. There are some boys that are in 10th grade. There are some boys that are not in 10th grade. That would be over here. And there are some 10th graders that are not boys. That would be over here. Okay? Now, you also have a situation here where what if instead A was still you're in 10th grade and B was you're in 11th grade? Okay, in that case, there are some people in 10th grade. There are some people in 11th grade. There is no one that is in both of those grades at the same time. Okay, that is not possible. It's one or the other. Okay, so those are 2 situations where we have compound events. 2 different kind of diagrams representing that. So if the 2 events for A and B, if we think about it, if we were counting A to represent that, we would say, or say we were trying to figure out what's the probability of being in A or B. So either being in 10th grade or a boy. So that'd be the probability of A. Okay, we want to know what the probability is that you're in 10th grade. Then we're going to add the probability of B. What's the probability of your boy? We'll add those 2 together. And then we're going to subtract the probability that you're both. The reason we have to subtract this probability that you're both, if we think about it, right here, this region, that is being counted for A and B. So if we count it for A right here and B, we have to subtract it out so that we don't double count it. Because if we just add A plus B, sometimes we might get a number that's more than 100%, okay? A ratio that's higher than 1, and that's not possible. And now, on the second one here, it says if they are mutually exclusive, right here, mutually exclusive. Now, that means they kind of to exclude the exclusive are kind of in a world of their own, right? So mutually exclusive means A doesn't mess with B, B doesn't mess with A, and we look right here, A and B are totally separate. So to find the probability of A or B, in this case, we could do just the probability of A plus the probability of B. We don't have to subtract anything out because nothing was double counted because these two do not overlap at all. Okay, so now let's take this probability of compound events and we'll kind of apply it. So if we look here, it says a 6-sided die is rolled. Okay, so that's a standard die. It says what's the probability of rolling a 5 or a multiple of 3? So let's first think the probability when you roll a 6-sided die of rolling a 5. There's 1 5 on it. It's 1, 2, 3, 4, 5, 6. So there's 1 5 out of 6. Okay, so we know that there's a 1/6 chance we'll roll a 5. Now, for a multiple of 3, that would be the number 3 and 6. Both of those are multiples of 3. So there is a 2 out of 6 chance. Okay. Now, at the end, we will want to reduce. However, we don't need to reduce until the end. So if we add those two together, 1/6 plus 2/6. Now let's decide, are these mutually exclusive? And the way we decide that, is it possible to roll a multiple of 5, roll a 5 that's a multiple of 3? And our answer is no, because a 5 is not a multiple of 3. So we don't have to subtract anything off. There's nothing that is part of both of them. They would be considered mutually exclusive. So 1/6 plus 2/6 gives us 3/6. Now that can reduce, and we're going to get 1/2. Okay, half of the options would either be a 5 or a multiple of 3. Okay, so probability of a compound event now. This is the exact same situation, except they're not mutually exclusive. So it says same 6-sided die is rolled. Okay, and it says what is the probability of rolling a multiple of 2? So if we think about that, that's 2, 4, and 6. So that's 3 of them. So it'd be 3/6. Okay, we're going to add that with what's the probability of rolling a multiple of 3? So that'd be, once again, 3 and 6, so plus 2/6. Okay, now in this case, if you look here, the 6 was counted for both of them. That is what is part of the shared. It's A and B. It satisfies both of them. Okay, and since it satisfies both, we have to subtract it. So there's only one number that satisfies both. So we'll subtract that 1/6. So 3/6 plus 2/6. 3 plus 2 is 5. Minus 1, that's going to leave us with 4/6. Okay. And now if we simplify that, our final answer will be 2/3. All right. So now, a couple more examples dealing with cards. First, another way to think about this, if we're finding the probability of A or B, one way you can think of it is we want to find the probability of one event and the probability, then we want to find the probability of the other event. And then we have to subtract the one that is both of them, the probability that both of them happen. Okay, so if we scroll down here, and it says in a deck of 52 cards, find the probability. An example one is a heart or an ace. So if we look here, all of our hearts, right here, and let me get my pen back. There are 13 of them, okay? So the probability that we get a heart would be 13 over 52. Okay, now we need to add, that's probability of one plus the probability of the other. So what's the probability you get an ace? Now for an ace, there's 1, 2, 3, 4. Okay, so the probability of rolling an ace, or pulling down an ace, is 4 out of 52. So now we have to subtract what is shared by both. Okay, if we look here, that's hopefully easy to see. This ace of hearts, we marked it as a heart and we marked it as an ace. So if you look right here, this ace of hearts is the only card that satisfies both of them. It's both an ace and it's a heart. So that's 1 out of 52 cards. So we have to subtract that 1, and we're left with 13 over 52 plus 4 over 52 minus 1 over 52. 13 plus 4 is 17 minus 1. That's going to give us 16 over 52. Okay, now at this point we do need to reduce. So what goes into both 16 and 52, and that would be 4. So we're going to be left with 4 over 13. Okay, now our example 2 here. It says, what's the probability that we get a 5 or a queen? Okay, so for this one, let me quick erase all this. A 5 or a queen. Now, this one is going to be mutually exclusive. It's not quite like the last one. And the reason why, there is no card that is both a 5 and a queen. Okay, it could be a 5. There's 4 of them. It could be a queen. There's 4 of those, but it could not be both. Okay, so for this one, all we have to do then is do 4. Let me get my pen back. 4 over 52 plus 4 over 52. We could subtract 0 if you want, because there's 0 cards that are both 5 and a queen. Or we can just leave it, and we'll get 8 over 52, which will reduce to 2 over 13. Okay, now let's talk about this one. What's the probability that we get a jack or a black card? Okay, so first let me erase these. Probability that we get a jack or a black card. So hopefully you know black cards, there's 13 spades, there's 13 clubs. Okay, so that results in 26 total out of 52. Sorry, that was event B. I should have done jack first, but hopefully over here you can see there are 4 jacks. So we're going to do 4 over 52 for event A. We add those two together. We have to subtract. Right here, there's the jack of clubs and the jack of spades. That's 2 cards that fit both of them. So 2 over 52. So 4 plus 26 is 30. 30 minus 2 gives us 28 over 52. And at this point, 4 goes into that 7 times, goes into 52 13 times. All right. So we're just about done. I'm going to skip this 4th one, and let's get down here one other type of example. So example 5, sometimes we won't be dealing with cards. It says, of 300 students, 52 of them played a sport, 68 worked a job, and 21 did both. What's the probability that a student is playing a sport or working a job? So if I choose a random student, what's the probability that they're either playing a sport or working a job? So if we think about it, event A is a sport. So we know that 52 out of the 300 are playing a sport. Event B is working a job, and we know that 68 out of the 300 are doing that. However, right now we are counting 21 of them twice. We're counting them as a sport and a job. So we have to subtract that 21 out. Okay, so 52 plus 68 minus 21. If we add all that together, 52 and 68, okay, that'll give us 120 minus 21 leaves us with 99 over 300. Okay, now at this point, they are both going to be divisible by 3. Okay, 3 will go into 99 33 times, and it will go into 300 100 times. So we're left with 33 over 100. There's a 33% chance, but we'll just leave it as 33 over 100. That's the probability we'll draw one. Okay. So if you have any questions, please let me know. I won't talk about this one today, but we'll keep going. And I hope you guys have a great weekend and try to get all your work done and caught up in algebra. Bye, guys.